Hello friends, today we are going to study the stress strain curve. We need to remember one thing, stress strain curve is only for ductile material. It is only for ductile material. In stress strain curve, in x-axis we will get strain change in elongation upon actual length, and in y-axis curve we used to plot stress that is load by area. In stress strain curve, initially it's above hook law. Point A is limit of proportionality. After that we are getting point B, where point B is elastic limit. After that point C we will get upper yield point. After that point D, I am going to explain all these point D, lower yield point. After that point E is ultimate tensile stress point. We will also call it as a ultimate state of stress or a uniaxial state of stress. After that we will get point F is fracture. Now we are going to explain all now I am going to explain all these points sequentially. Up to point A, in stress strain curve, up to point A we are getting limit of proportionality. Limit of proportionality means stress is directly proportional to strain. If I are going to apply the stress, strain is also going to increase. It is a limit of proportionality. After that at point B we are getting elastic limit. There is a difference between limit of proportionality and elastic limit. Elastic limits is the limit point up to which if we increase further stress, it will not going to increase the strain point. After that C, after upper yield point. Up to point E we need to remember one thing also. Up to point B hook laws above. Then upper yield point. Upper yield point is the point where it does not avoid the hook laws, but after further that point, if you apply the stress, strain is going to decrease. Means, for example, if you apply stress in less amount, strain is going to increase in greater amount. That is the upper yield point. Lower is point up to the lower yield point, and lower is point is the point up to in which if you apply the stress point, strain point is also going to increase. This is because the strain hardening. Strain hardening. I am going to explain this strain hardening with one example. Like suppose we have spring. If you are going to apply the tensile force in UTM machine with this spring, it opposes the hook loss up to point B, after that lower point. But at some point, if you notice that after lower yield point, if you apply stress point, we have to apply more stress point in order to increase the strain amount. That is strain hardening. Strain hardening is also called strain hardening is also the process of hardening in manufacturing process. You are getting this strain point up to the point E, that is ultimate tensile strength. Ultimate tensile strength or ultimate tensile stress point is the point where you get the maximum stress value. We cannot apply a stress point after that. If you are going to apply the stress point after the ultimate stress point, we are going to, the material is going to fracture. We need to also remember one thing: stress strain in stress strain graph is engineering stress and strain. We are not going to draw the graph with true stress and strain. There is a difference between engineering stress and strain and true stress and strain. In order to understand the true stress and if you draw the stress strain curve for any ductile material, we are going to get this graph as this. This is for true stress and strain. There is a key difference between the engineering stress strain and true stress strain. For example, engineering stress, that is load by area. Suppose we have this tube. We are going to assume the cross section of this tube is always constant in stress strain curve, but in true stress strain curve, true stress area is not constant. It yields necking. I am going to explain this necking point. From point E into F, we are getting the point necking. See, this is the tube, right? If you apply the tensile force, it is going to behave as this. At some point, it cross section become very small and it automatically fracture. This is the necking process. And stress strain curve is only for ductile material. Ductile material is a material in which we can, and in which material can be elongated, and it is not for tensile it is not for brittle material, because brittle material does not behave hook laws, and and cannot plot a stress strain graph for brittle material, because it fracture without obeying Hooke's law. See, for ductile material, for brittle material, negligible change in dimension and break spontaneously. And the best example for the brittle material is glass material. Thank you, friends. I'll going to attach this note in description. Please like and share it. Thank you.